That's not right. All right, much better. Hi, everyone. Let's go ahead and get started. We have a lot to talk about today. I've got the whole day set aside to talk to you about the homework assignment. So this is going to be a recurring thing for this class. I think I've got a day basically set aside for each homework assignment. In part, so for this first one, a lot of it's just setup stuff. We won't need that for the later ones, but for the later ones, I like to have conversations about how the homework assignments tie into what we've been talking about during class. So I think it's really important to take some time, have those discussions. Today, though, it's going to be a lot of setup stuff for you guys. The good news is that you should only have to do this setup stuff once, so it should be a lot more straightforward on future homework assignments. You can find the write-up for this homework assignment on Canvas. It should be live. I hope it's live. I told it to be, so I hope that it is. And the way that this is set up, I have created a repository with some starter code in it, and then also some empty methods that you're going to have to fill out as part of the assignment. So if you haven't done this for another class in the past, you're going to need a Bitbucket account. So I gave you a link to Bitbucket. It's just a website like GitHub, very similar to GitHub for hosting Git repositories. So you'll need a Bitbucket account, and then once you have your Bitbucket account, I want to walk you through the process of actually creating your repository, because it's very important to get this set up in a particular way so that we can grade your assignments effectively and you guys get your assignments graded. So assuming that you've already got a Bitbucket account, which takes like 2 seconds to sign up for if you don't have one already, there's a link here to the repository page for the assignment. So you can go ahead and click on that link. And it should take you here. Should take you to a page that looks like this. And down below here, you can actually see, right, all of the files. So I'll go over what's in these files in a little bit. We'll go over the assignment, talk about what you have to do. Right now, I'm just interested in you getting a copy of these for you to work on. And again, remember too, I guess now's a good time to mention that you can work with one other person, so one partner if you want to, right? So hopefully you've already kind of figured that out. When you're ready to get a copy of this for yourself to work on, there's a plus sign over here on the left-hand side of the screen. I'm gonna click on that. And then down at the bottom, it says fork this repository. So if you're logged into your Bitbucket account, you can click this link. This is gonna give you your own personal copy, but don't rush through this, because I want you to do a few things as you create this repository. We don't actually need this. The most important thing for you to do right now is to add your last name, and if you're working with a partner, put your partner's last name on here as well. So my last name is Shook, so I'll type my last name on the end of this. If I had a partner, I put my partner's last name on the end of this as well, right? There's a box below here that says access level. This is a private repository. That should be checked. Please check that box. That is for integrity purposes, right? If you don't check that box, your work is going to be publicly accessible, and then there are academic integrity implications of having your work publicly accessible like that. So please check that box to indicate that it's a private repository. So put your name on the end, your last name, and check that it's a private repository, and then you can go ahead and click the big blue button. Bitbucket will do some work. This is the part where my phone blows up with emails from everybody making the repository. You should now have your own copy, but we're not done. There's still some setup stuff to do, right? So if you're working with a partner, you need to add your partner to this to this repository so that they can access the code. If you're working with a partner, I don't need 2 different copies. I just need 1 copy for your group, right? So I just need 1 copy for both you and your partner. So instead of each of you making a copy, just make 1 copy, and then you can add your partner by going, oh, I had it. All right, by going down here to settings on the left side, should be a button called settings. We are interested in user and group access settings. And then there's a box, add user by their name. So you can type in their email address or their username. They'll have to tell you what it is, right? I don't know what it is. They'll have to tell you what it is. And then you probably want to give them at least write, if not admin permissions on this repository. But while you're here, there's one other thing I want you to do. Yeah, question.
Sorry, I don't think you can do username lookup anymore. At least I wasn't having any luck.
Oh, really? So it only goes by email?
Yeah.
Okay.
That's what it instructs you to do.
Okay, that's fine. Either way, however you get there, right? As long as you get your partner on there. But I also want you to add the course account, because that's the account that we're going to use to grade your assignments. So whether you have a partner or not, I need you to go to this screen, go to settings, go to users and accounts, and then add the course account, which is CSE530. I mean, for me, it just popped up when I typed CSE530. You might have to type CSE5, well, that didn't work at all, right? That's the email address, gmail.com, CSE530woosel@gmail.com, or CSE530 works for me. I don't know if that works for you guys. Anybody figure out the magic words to get it to pop up in the box? Either way, I need you to give me at least write permissions on this repository, because I'm going to put your grades back in here. And if you don't give me write permissions, I can't tell you what your grade is. So please, please, please look up the course account, CSE530. Give us at least write permissions, at least, so that we can check out your work, grade it, and then put the grade back in your repository. If you got lost somewhere, if something I said was a little confusing to you, don't worry. Everything that I just said is right here in the first couple paragraphs of the write-up. So if you got stuck somewhere along the way, come up after class, I'll help you out. Take a look at the instructions after class. It details everything that I just said, right? And again, you only really have to do this once. You only really have to do this the one time. Once you get up and running, we don't have to worry about this again. Other assignments will be a lot easier to get set up. Are there any questions right now about grabbing the code, about doing how many of you in here have used Git before? Oh, fantastic. That's what I like to see. A few years ago, I did not see very many hands when I asked that question, so this was kind of a sad day. But that's changing for the better. It makes me very happy to see so many hands up. If you have not used Git before, if you are hearing me talk about all this Git stuff and you're like, what the hell? Don't worry. We're not going to be doing anything terribly crazy with Git, although at this level I do expect you to be able to have at least a basic knowledge of it. I'd be happy to point you to some tutorial resources online if Git is something that's new to you, just to show you some of the basics. But we will be using Git for all of the assignments, and actually to turn an assignment in, all you have to do is commit it to your repository by the due date. That's all you got to do. You don't have to tell me, you don't have to send me an email, you don't have to do anything. Just commit it to your repository by the due date. We'll take it from there. Any questions so far? All right, yes?
So on that page, you only says the username of CSE530, so can we also get an email first?
I can put the email on there, yeah?
Yeah.
On this page, you mean? The one that I'm looking at?
Yes.
Okay. Yeah, it's just this@gmail.com, but I can add that on there.
Oh, okay.
So once you've got the repository, you probably want to load it up in an IDE, I'm assuming. So I have things set up to use Eclipse just because that's what a lot of classes use around here, although that's starting to change. I know that if you want to use IntelliJ, that's been done in the past without any problem. So if you like IntelliJ better as an IDE, go ahead and use it. I'm not sure about other IDEs, but I would assume it would be okay with other environments as well. I have instructions for Eclipse. I'm going to be using Eclipse just because that's what I've got history with. So once you've gone through this process on Bitbucket, you've added your partners, you've added our account so that we can grade it, you need to load it up into Eclipse. And that's a pretty straightforward process. If you've taken classes with Eclipse before, you probably already know how to do this. In fact, I link you to the 131 instructions because it's exactly the same as it is in our intro class as it is for this class. So I'm not going to go through that process right now. I'm going to assume that you're smart enough to read the instructions and follow through that process yourself if you don't already know how to do it. But then at the end of the day, what you should hopefully end up with is something that looks like this, where I can see this is Eclipse. For those of you who aren't terribly familiar with it, this is Eclipse, where I can see the files over here. I've got a couple packages, one called Homework 1, one called Test. I know that text is really small. I promise you the code window text is a lot bigger, so you'll be able to actually read it. And what I'm going to do next is kind of give you a tour of what files are in here, what they represent, and what you need to do on this assignment. But let me pause real quick, make sure there aren't any questions before we move on. We good? All right. So let's take a quick tour then of the assignment itself, talk about what I'm asking you to do and how that relates to the stuff that we talked about in class last week. This assignment is all about the physical layer. So I'm asking you to implement the physical layer for our database implementation, but we're going to make some assumptions. We're going to make some restrictions on ourselves to keep things simpler for us. So some things to think about with our database. We're going to limit ourselves to 2 data types, which I know is not very many at all, but it's enough to get what we want done. The 2 data types that we're going to use are ints and strings. Okay? We talked about data types a lot last time, right? What that means for us in terms of this assignment is we have to have a way of reading ints and strings out of the files, out of the heap files, right? And then also writing the ints and strings back into the heap files as well. So with that in mind, it's important to make some distinctions about those data types as well. For instance, the ints are all going to take up 4 bytes every time. 4-byte integers, which is the same as they are in Java, so that's nice and simple. 4 bytes. The strings are a little bit more complicated. So we talked last time about how there are different types of string implementations on most databases, right? What's the primary difference between string implementations that we talked about? What are the 2 kinds of strings that we discussed? I'm sorry? Care and varchar, thank you. Yeah. That's right. Care and varchar. I'm getting through to you. Varchar is like doubly bad because it's not a variable character. That's like how a pirate would say it, man. Anyway, sorry. Yes, care and varchar. So what's the difference between those 2? Padding. So one of them is variable length and one of them is not, right? We're going to use the one that's not variable length. Again, just to keep things simple. Having variable length rows in our heap files makes things more complicated. We're going to keep things simple. We're going to use fixed length rows. So every single row in our database is going to be made up of multiple columns, and those columns can be ints and strings. And the ints and strings can appear in whatever order they need to, right? And I can have multiple int columns and multiple string columns if I want, but it's all going to be fixed size. So for our strings, I want to make this clear, right? For our strings, they're all fixed length, but the format still requires a little bit of extra information, because if I have a fixed length string, most of the time I'm probably only going to be using part of that with actual data, right? And the rest of it's just going to be padded out with spaces. So I still need to have some idea of how long the actual string is, so I know where the padding starts, so that I can, chop it off when I need to, get rid of it when I'm ready to process that string. So with that in mind, our string format is going to take, our strings are going to take the following format. I can try and draw it out in a little diagram, hopefully. Is my pen broken? Hello? No? Maybe the battery's dead. Oh, there it goes. All right. So we're going to use the following format for our strings. I just want a white screen. Perfect. I'm going to have 1 byte up front, which represents the length of the string. And then I'll have a whole bunch of characters afterwards. This is the actual string itself. But keep in mind that some of this stuff is padding. So if I have a length of 2 here, that means I can have 2 characters, HI, but then everything else that comes after this is padding. And it's going to be padded out so that every string is exactly the same length. So this portion here is going to be 128 bytes, or 128 characters, however you want to see it, plus 1 byte for the length gives us a total size of our strings of 129 bytes per string. That might seem a little odd to you or frustrating to you that it's not a nice even power of 2, but it doesn't have to be. It doesn't have to be, right? We're designing the database. I know I'm kind of designing the database right now, but we are the ones who are setting this up. And so it's, we can make it as long or as short as we want to. This allows us to store strings of up to 128 characters long, but not more than that. We have strings that are longer than that. We're out of luck. We're making a simplification just to try and keep things simple and straightforward. Are there any questions about that? So we've got our 2 data types. We've got ints, and we've got strings. And so now we can kind of envision, right, what the file structure might look like. If I look at a heap file, what do I see inside the heap file? Heap pages, right? And so then what do I see inside of a heap page? What are the components of a heap page? Records. What comes before the records, though? The header. So I've got the header, and then I've got the records. Got the header, and I've got the records. And so what I'm asking you to implement as part of this assignment, right? This tuple class and the associated class tuple description, those are going to be records. Those are going to be records. A single tuple is going to represent 1 row of data in my database. What table does it belong to? I don't know. We'll have other ways of figuring that out. Actually, you can see that there are getters and setters here for page ID where the tuple is stored, and then tuple slot where it's stored, right? So the tuple itself is somewhat aware of where it belongs, what page it lives on, what slot it lives on. But in general, this tuple is just a storage of data, just a storage of information, data. The ints and strings that comprise that row of data. The tuple description is what we might call metadata, right? It tells us that the first column is an integer, and the name of that column is, I don't know, age. The second column is a string, and the name of that column is address, right? So a tuple description is a list of types and names for the columns. And there are some methods in here that I've asked you to implement. You can see that ahead of a lot of these methods are descriptions as to what that method actually does. The write-up also contains some information, some hints, some tips on what these methods are supposed to do. So you can refer to that to help out as well. So that's kind of the first step, is a way of defining our records. Once we've got that done, then we can dive into the meat of this assignment. I think the bulk of the work of this assignment is going to come in heap file and heap page. This is where most of your time is probably going to be spent. So you can see that heap page has some work done for you already, but there's a lot of methods down here. Here's one, actually, get number of slots. We did this in class last week. So if you were here, you're paying attention, you have the answer to this. You just got to turn it into code, right? There's some other methods down here, get header size, which is very much related to the number of slots, right? Very, very much related to the number of slots. So you'll have to do some arithmetic here. You'll have to do some math to figure out how to compute these values and return the appropriate values. You can check to see if a position's occupied or not. So if I want to see if a slot's occupied, got to find the right place in the header, right? See if it's 0 or a 1. Exactly, right? See if that particular position is occupied. I can also flip bits, right? I can set bits to be either a 0 or a 1 if a slot becomes occupied or a slot is no longer occupied in the case of a deletion. And then the real fun stuff is down here where we perform the actual operations. The addition of tuples, the deletion of tuples, right? To the heap file. So there shouldn't be anything in here that's too much of a surprise, hopefully. We talked about almost all of these concepts in class last Wednesday. And remember, we have a hierarchy here, right? The heap page is in charge of managing where tuples live, where records live in the file. The heap file then, which is our next destination, is in charge of managing the heap pages themselves. So everything that I see in the heap file class is going to be related to page management. You want to look up a tuple? Let me find what page that tuple is on. You want to insert a new tuple? Let me find a page that has an open spot in it so that you can insert that record into that page. So the heap file has lots of things that involve page management. So some simple getters up at the top, and then read page, right? So you can think of the heap file as just an array of pages. So if I give you ID 0, give me the first page. If I give you ID 7, go through the array of pages, give me the whatever page, right? Write page is like read page, just in reverse. You are going to have to do some file manipulation here. You are going to have to do some file manipulation, and that can get a little tricky. Let me give you one big hint on the file stuff that I see a lot on this assignment. If you open the file, you got to remember to close it. If you don't close it, the next time you try to open it, it's not going to work. Your whole thing's going to crash. I see it a lot. A lot of times when people have problems on this assignment, it's because they either forgot to close or they thought they were closing, but their closing statement was in like an if statement or something. Don't do that. Make sure it's closed. Do whatever you got to do. Make sure that file's closed. Please. Adding tuples, deleting tuples, getting all tuples. Yeah. Any questions so far? I've got a couple other things to talk to you about. Yeah.
We need to create a helper method to be able to do that.
Yeah, go nuts. You can create whatever methods you need to get the job done. All I ask is that you don't change the signatures of the methods that I gave you, because we're going to be testing. We're going to be running tests on those exact methods. We're going to expect certain output to come back. So if you want to add your own methods in, go nuts. I have no problem with that at all. Any other questions I can help you with? Yes?
Do you provide a unit test?
We're going to talk about that. Yeah, that's a good question. We're going to talk about that. That's coming up on my to-do list about unit testing. Good question. Any other questions right now? Yes?
Just making sure the ID we are talking about is the ID of the.
I'm sorry?
The ID, the get ID. Yeah, the ID, the get ID. Oh yeah, that one.
So this is the page number,
Okay.
because a heap file is an array of heap pages, basically. Yep. Any other questions? All right, so then the last piece for you to consider is this file that I've got here called catalog. The catalog is actually where we store not the data, but the data about the data, or the metadata. We've been talking about that in class 2, right? We're going to store the metadata. So the metadata in this case is actually represented by some of the structures that we have, like the tuple description. That's an example of metadata. Or another example of metadata might be if I want to query information from this table, what file is that data in? Where is the file that I can look up to find that data? That's another example of metadata. So the catalog is going to be in charge of managing this metadata. And what that means for you, for the sake of this assignment, is that you need to have ways of adding in tables. So in this case, there's a one-to-one relationship between a heap file and a table. So every table in our database has one heap file associated with it. But when I create a table, I have to register that with the catalog so that I know how to look it up later when I need to access that data. I also might want to know the table ID, which is just a unique number associated with the table in case the name of a table might have some kind of a conflict. Or I might want to know what the tuple description is for a particular table. So tell me what the columns are and the data types of the columns are for this particular table, which is going to be useful in future labs when we want to do things like write queries, make sure that the things that I'm querying for match the data types, right? It may not be super useful for us immediately in this lab, but it will definitely come in handy in future labs. And there's some other kind of housekeeping methods here. This process of tracking metadata might require you to make a small little data class, small little structural class to use. In Java, you can use an inner class for that without too much trouble. So that's kind of a big hint. I think it's on the write-up anyway for that. So you might want to have some way of keeping track of what the tuple description is or what the name of the table is for a given table, and then a way of looking that up, or a couple ways of looking that up based on the table name or the table ID or whatever the case is that we need to look up the table by. So those are the only things that you have to actually write code for in this assignment. You can see that there are some other files here, but these files are mostly just support and structural files. If it's not one of the files that I just showed you, you should not have to change it. You should not have to manipulate. In fact, I would encourage you not to do that unless there's a really, really good reason to do so. Every once in a while, there's a bug in the code that requires changes to be made, but I certainly don't anticipate that happening. So stick with the files that I talked about. Although it's good to know what these files are for, you can see I've actually got two classes, int field and string field, which represent the two data types that we can use, right? So it's really just a wrapper class for those two data types that we can use to easily talk about them in our code. And it also provides some convenience functions, such as converting an int to an array of bytes. That's going to become very handy when you're trying to take this value and write it out to a file, because a file is going to want bytes, right? File is dealing with bytes. So there's code here to convert things to byte arrays, and vice versa as well. And the string field is very similar. Trying to think if there's anything else. Oh yeah, the database class. You shouldn't have to mess with this class either, but this is a good class to be aware of at any rate. This class uses a design pattern called the singleton pattern. So basically, I only want there to be one instance of the database running at a given point in time. I don't want to have multiple databases competing with each other. And within a database, I also only want one instance of a catalog running, which makes sense. I don't want to store my metadata in multiple spots. There's actually cases where we might want to do that. We'll talk about that much later in the course. But for now, I want to make sure that all my metadata, all my information is stored in a single place, in a single catalog. So this file sets up the singleton pattern for those things, just to make sure that we're not going to inadvertently create multiple catalogs or multiple databases, or at least makes it more difficult to do so. Let's see. Let me go to the write-up real quick, make sure I didn't skip anything too terribly silly. I don't think so. For each of the classes that I talked about, I gave you some implementation hints, so please take a look at these carefully. Yeah. Please read over those carefully, and if you have questions, you know how to get a hold of me. Let's see. Let's talk about testing. Unless there's questions. All right, let's talk about testing. So it was asked earlier if I'm going to give you unit tests, and the answer is kind of. I have another package here called test. And inside of this package, you can see there's things called catalog tests and heap file tests and heap page tests. So there are tests that I am giving to you But what I want to talk to you about for a big chunk of the remaining time that we have is how to properly test your code and submit it. Because I think I would be doing you a disservice by giving you a bunch of unit tests and using that to grade your code. That's not how life works. That's not how things happen. If I sit down and I want to make a new program, the unit test fairy doesn't come and plop a bunch of unit tests in my lap that I can code a spec to, right? That's not how it works. I have to write the tests. I have to write the tests, or my team has to write the tests. And so you guys are going to help me write these tests, which I know is something that not a lot of people maybe have done before. I know that some classes talk about unit testing, but not as many as I personally would like. So we're going to spend some time talking about unit testing in this class, how to write good unit tests, what different kinds of unit tests exist. And for every assignment, I'm going to expect you to contribute some unit tests that we can use to test our programs. So here's how it's going to work. For every assignment, I'll supply you a few tests. I'm going to be perfectly honest with you. Those tests, the tests that I give you, are not always that great. Sometimes that's intentional. Sometimes it's not a great test. The idea here is just to give you a feel for how the code is maybe kind of supposed to work a little bit, give you some ideas of how things could possibly be tested. And then what I want you to do is actually write some tests and give them back to me. I usually give you a couple days to do this. So writing unit tests is not supposed to be a very time-consuming process. We'll often have brainstorming sessions here in class about what can be tested, what kinds of things we want to test. And so by the time you leave here on assignment days, you should already have a good idea of what could be tested, right? What kinds of tests could be written, and the tests themselves should be pretty short. We'll actually maybe write some tests now in class because we have the time to do that. And then a couple days from now, I'll expect you to have committed your tests to your repository. I or my TAs or some combination of the two will then grab all of the tests that you have submitted, pull out the ones that look good, package them all up, and then give them back to all of you that you can then use to test your assignment before you turn it in. That's how these homework assignments are going to work. So I'm not going to give you unit tests to test your stuff. You're going to write your own unit tests, which are going to be shared through the class. That makes things a lot more fun too, because then you as a class get to decide certain behaviors about these homework assignments, right? How I write the tests actually defines how the behavior of the program is supposed to work. When I write a test, I'm really writing a contract, right? I'm saying, I want to be able to call this method and do this thing and see this result. So I can actually define the behavior of the program that I'm trying to write. So you as a class now have influence, have control over how these assignments are supposed to work, how they're supposed to behave. So let's take a look at some of the tests that I've given you and talk about how to write good unit tests and talk about what some potential areas are for writing unit tests, and maybe even write a few unit tests in class right now and see where that gets us. So I'm going to open up, which one of these? Well, I've already got this one open, heap page test, so I might as well stick with this. So in Java, the most prevalent unit testing framework that I know of is JUnit. Not the only one, but it's everywhere. We use it a lot in our classes here, so we're going to use it for this class as well. And a test is a class, just like any other class, but it's got these special things in it. Anybody know what the technical term is for one of these guys? It's an annotation. Good, thank you. It's an annotation. And so I'm going to write methods in this class, and then I'm going to annotate those methods. Actually, I missed an annotation here. Whoops. My fault. That's okay. That'll get fixed when you guys write some tests for me. And so the annotations that you see in this file, there's only two of them. I see test. I see that appear above a couple methods. Those are the actual tests that are going to get run on my code. The other annotation that I see up here is one called before. So this method is going to get run before every single unit test. So if I have some code that I want, some setup code, some prep work that needs to be run before every unit test, I can use this before an annotation. And that's what I've done here. So let's walk through this and see, what exactly is happening, how this code is actually working. You can see that I've got some instance variables up here for a heap file and a heap page and a catalog and a tuple description. Those are the things that we're testing. Those are the things that we need to test. So in my setup code, the first thing that you can see that it does is it tries to make a copy. And the reason that it does this, right? I've actually given you some test data. I've given you some data to use to test your stuff. I'll show you that data in a little bit and explain what the structure of that looks like. But the data could potentially get screwed up, right? If your code doesn't work exactly right, you make a mistake somewhere along the way, it could corrupt your data. So I've given you a backup file, and what this is doing is it's throwing out the existing copy of your database and starting fresh with a new copy so that we know exactly what's in there in case it got screwed up earlier on. The next thing that it does is it tries to set up these instance variables. It gets the catalog, it loads this table. This is a table called test. It's going to load the test data so that I can then try to do things with it later on in my unit tests. So it grabs a tuple description, it grabs the heap file, and it grabs a heap page, right? This setup method is just doing some basic structural stuff. In fact, I certainly welcome you to use this setup method when you're thinking about writing unit tests of your own. You have my permission to go ahead and use this code if it will help you. Then if we look at the actual tests themselves, you can see that I've got a couple of them down here. I've got one called test getters. You can see that it checks to make sure that the heap page has 30 slots in it. How did it compute that again? What are the variables involved with the number of slots? We went through that formula in class last week. Yeah. Page length and record length. That's right. Page length and record length. So based on the page length and the record length of this particular heap page, right, there should be 30 slots. You might be asking, well, what is the page length? What is the record length? We can actually figure that out. The page length is coded as a constant. Where is that? It's in heap file. Yeah, there it is. Coded as a constant. 4 kilobytes, right? So every page is going to be 4 kilobytes in length. The record size, we can take a look at in this test files folder. You can see this is all the sample data. So if I open this test.txt file, I can see that, I can't zoom in, please. Sorry, no? Well, you might just have to take my word for it because I know the text is tiny. There's an integer and a string. So based on that, I can compute the size of a record. It's 129 plus 4, so 133 bytes, right? And it's telling me that I can fit 30 of those records in a 4 kilobyte page. And the test is checking to make sure that that was computed properly by calling the getNumberOfSlots method in the heap page class. So until you implement that method, this is going to fail. This test isn't going to work. It's also checking to make sure that the first slot is occupied, which is true. I've actually given you some data. There's data in these files. There's actually already records. There's already tuples in these files so that we can use these for testing purposes. I can show you that in just a little bit. And then it's going to go through and make sure that all of the other slots are not occupied. So basically there's one tuple in here. There's one record in this file. It's looking it up to make sure that, yes, I've got this many slots. Yes, I see that the first slot is occupied and all the other slots are not occupied. That's all the test is doing. Very simple, very straightforward. Not trying to do anything complicated. I've got another one down here for adding a tuple. So I'm not going to go through this in as much detail line by line, but just the quick overview, right? I'm making a new tuple and giving it some data. I'm going to try to add it to the heap page. And then I'm going to grab the heap page iterator and verify using the iterator that I now have 2 tuples in my file. One that was already in there plus the one that I added. So there are now 2 tuples in that file. And that's it. That's all that test is doing. Make a tuple, add it. Can I see that there's now 2 tuples in there? And delete is kind of the same thing, but the opposite. There's 1 tuple in there. I'm going to delete it and make sure that the file is now empty. Right? Notice that with these tests and with all unit tests that I'm expecting you to write for this assignment, they're very narrow focused. I'm not writing a test that tries to do 100 different things. I'm writing a test that sets up the testing conditions, calls the method that I want to test, and then verifies the results. Those are the 3 steps of writing a good unit test. Set up the testing conditions. So for the case of add tuple, right? Setting up the testing conditions means making a tuple for me to add. Calling the method that I want to test. In the case of this test, that means calling the add tuple method, passing the tuple that I created, and then verifying the results. That's this part down here. Using the iterator to make sure that I have the proper number of tuples in the file. I want to test 1 method per test. Now, I might want to test 1 method multiple times. I might want to write multiple tests for 1 method. That's totally okay. But I want to write 1 test. Or, I'm sorry, I want to test 1 method at most per unit test. At least right now. As we go on through the semester, we might look at some more complicated kinds of testing. But for right now, I'm going to try and keep it as simple, as straightforward as possible. So there's already some things that are kind of a problem with these tests that I think you could argue could be improved. Does anybody have any ideas of improvement for the add or delete tests that I've just been talking about that you see?
Random numbers instead of the set.
I could use random numbers instead of the set numbers, although I don't think that using random numbers is even going to be that big of a deal, because right now I'm not even checking the contents of the data in the file. I'm only checking that the records exist. You could have written something totally different in there, but as long as you have the right number of tuples in the file, I'm saying that's good. That's important, but it's not the full story, right? If I really wanted to thoroughly test it, I would not want to make sure that I have the right number of tuples and the content of those tuples is also correct. So I kind of stopped short a little bit. That's an area that you could consider writing a unit test for this particular assignment. Was one other thing I was going to say, and it just flew out of my head. What was it? I forgot. Does anybody else have any questions while I try to remember what I was going to say? So if you're looking for things to test, right? Open up the file that you're interested in testing. Maybe I'm interested in testing some of the things in the heap file class. Find a method. I want to test read page. All right. Think about what that means. Read page returns a heap page. So I could try giving it various IDs and making sure that I get the correct heap pages back when I do that. Right? Getters, I'm usually not as interested in testing, although for right now, I'm not going to argue too much if you decide to test some getters. I prefer that you didn't, because getters are usually very straightforward. They're usually one-liners, usually not worth writing unit tests for. So I'm interested in testing some of the more complicated kinds of things, like reading pages, writing pages. So for writing pages, right? Write a new page and make sure that the heap file now has the appropriate number of pages in it. Something along those lines. For this first assignment, let's talk about grading for a second, because while we're on the topic, you'll notice that I have a rubric here that describes exactly how the points of this assignment are broken down across the various things that I'm asking you to do. And for this first assignment only, I'm not strictly requiring you to write unit tests, but I will give you a little bit of extra credit for doing so, right? In the future, I'm going to expect you to write unit tests. So I'm giving you a little bit of a learning curve here. First time, no harm, no foul. I find that the first time people write unit tests, they're not always great, which is to be expected. You haven't had a lot of practice doing it. We'll give you some feedback. We'll get some practice doing it. We'll keep talking about it over the course of the semester. So the first time I'm going to give you 5 extra credit points just for trying, just for giving me 2 unit tests by noon this Friday. Just write 2 unit tests sometime by noon this Friday. Send them in to me. You'll get extra credit just for doing that. And like I said, I'll then collect the good ones and distribute them out to you all that you can use on the actual assignment itself. What questions do you have? Yes? All you have to do is commit by noon on Friday. That's all you got to do. I gave you a file to do it in. So there's a file here called Your Unit Tests. I even copied over this setup method. You are more than welcome to use it. If you don't want to use it, just comment it out, right? Get rid of it if you want to. That's fine. But you're more than welcome to use it if you want. I think it's a good idea. I would encourage you to use it. The actual test is down here. You can see right now it's not doing anything, right? But remember the three pieces of a successful unit test. I've got to set up the testing conditions, call the method that I'm trying to test, verify that the results are what I expect. So choose simple conditions that you know the outcome of, so that you can easily check the outcome of that test, right? I've got a couple more things to chat with you about. One of them is to actually open up one of these files real quick and show you what the structure of that file looks like a little bit. But before I do, are there any questions about unit tests or anything else along those lines? Yes?
When it said there that you can conduct poorly formatted code and just unit testing program,
Where does it say that? Oh, this was meant to be in general, yeah. I put this here because there were a few students over the last few years who just turned in some absolute garbage code. It worked, but I couldn't read it. It would have to be bad before I start consider doing this, right? I'm not going to sit there and nitpick how many tabs you put in front of every single line. That's not what this is for. This is just so that you do some basic upkeep on your code, so that I can read it easily. I code all the time, guys. I know it's not going to be pristine, right? That's not what I'm looking for. Just please put a little bit of effort into making it readable for me. It'll make your grading easier as well. Any other questions I can answer about grading, unit tests? I know we've covered a lot of stuff today, so if there's any questions, I do want to show you one of these files real quick and show you what that looks like. So remember that the physical format of this data is in binary. These files are all in binary, which makes them very difficult for us to understand, but not impossible. It's not impossible for us to understand the contents of these files. So anything you see that's got dat in it, a.dat, test.dat, those are meant to be actual heap files. Those are actual heap files, right? That your code should be able to properly read and write to. And so in order to examine one of these properly, you need a hex editor. That's the truth of the matter. If you already have a hex editor, great. I would imagine most of you, how many of you have used the hex editor before? Yeah, that's what I thought. It's not the most common thing in the world. It's not that scary either, right? I know that a good chunk of you are at least aware of what hexadecimal is because you've probably taken 132, I hope, at some point. Or maybe you saw it in some other class. It's just a way for us to easily visualize data that's in binary files. So I have a hex editor on my machine, and I can open up one of these files real quick and show you what it looks like in here. Let me see if I can zoom in on this so you can actually see it. Come on. Window? Tile? No. No, that doesn't seem like it would do it. Is there really no way to zoom in on this guy? That's a tragedy. Options. Ah, maybe? Colors. Oh, here we go. Font. Found it. Make it nice and big. Oh gosh, okay. Good enough. This is a heap file. We're looking at it in a hex editor. I told you that there are 30 slots in this heap file. So how many bytes should I need in the header? For 30 slots. A little less than 4. I'm not going to chop a byte into pieces though, so the answer is 4. Yeah. That means there's a couple extra bits in the header that are just unused, wasted space, right? And we talked about that trade-off many times over the last couple of classes, right? There should be 4 bytes in the header, and so you can actually see the first 4 bytes here. There's nothing to distinguish them, but I know, because of the format that we talked about, these first 4 bytes are the header, and of that, the first one is the one that actually looks like it's doing something. You can see that it's a 1. So, you know, refresher of what hexadecimal is, that's 7 zeros and then a 1. Think about what that means. Think about what that means. That 1 represents that slot 0 is occupied, but that 1 is all the way on the right-hand side of the byte, right? It's little endian. Yeah. So if I'm figuring out what the slots are, right? Maybe a diagram would help with this. If I can bust out my pen, we can talk about what this header looks like a little bit. Can I get a new blank page or erase this page, I guess? If I'm thinking about what that means for the header, this is what that byte looks like, right? Each one of these bits represents whether or not a slot is occupied, but what slot are they referring to? This is referring to slot 0. This is referring to slot 1. This is referring to slot 2, 3, 4, 5. Does that make sense? 6, 7. The next byte, right, the farthest right bit would represent slot number 8, 9, 10, 11, 12, right? Does that make sense? Does that make sense? So if I go back to my heap file here, it's telling me that slot 0 is occupied. And we know from earlier that the form that this record takes is an int and a string. Okay? So the record's going to start after the header's over. As soon as the header's done, I should expect the record to start. So 1, 2, 3, 4 bytes. So this byte here is the first byte of my first record, the record in slot 0. And I know that this is actually the beginning of an int, which takes up 4 bytes. So the next 4 bytes that I have here, 0, 0, 2, and 12, those 4 bytes comprise my integer. This is in hexadecimal, so the number is not 212. Actually, this number, I could ask you to figure it out, but I'll just tell you, this number is 530, the course number. 530. Okay? And then the next thing that should show up in the record is a string. But remember that a string is 1 byte that indicates the length of the string, followed by 128 bytes, which is the actual characters. And a lot of those 128 bytes might just be spaces. So if I look here, this byte here is telling me that my string has a length of 2. And then here are the actual character data, which I think the hex editor will tell me says hi, right? Says hi. And then I've got a whole bunch of zeros after here that represent padding to make it the appropriate length. So where does the next slot start? That's not an easy question. It takes a little bit of math to figure out, right? Where does the next slot start? I mean, the easy way to say that is it starts 128 bytes after this one, right? 128 bytes after this one. But the point I'm trying to make here is there's no mark. There's nothing in this file that says, all right, this one's over. I'm about to begin the next one. Nope, nope. I just have to know this is the format of my file. Once I get through that number of bytes, I'm now on the next record. I've got 4 bytes of integer, 129 bytes of string. And it's up to us in the program, in the heap file class and the heap page class, to make sure that we respect those boundaries. Does that make sense? The file itself is not going to concern itself with that. So if you want to especially for testing. The reason why I wanted to show you this is partially so you understand the format of the file that we're working with, and you can actually open up this file as you run your code and see the changes that are being made and see if it's doing what you expect it to do, right? That's one good thing you can do with this file. You could also actually use this for testing purposes, for writing unit tests. You can make a file that's got certain data in it and then write some tests based on what data is expected to be in that file. That's fine. You could do that if you wanted to. You know, lots of options of what you could do with this information. A lot of students think that this is, you know, too much and there's already enough going on. They don't want to mess with it. That's fine too. You don't have to do this. You don't have to download a hex editor and mess with this file if you don't want to. Not required, but I did want to bring it to your attention, make you aware that that information is there so that you know how to interpret it. You know how to deal with it. Any questions? So right now, I guess one final thing about this file before I move on to something else. If I scroll all the way down here, you can see the file actually ends. This is actually one heap page. We're looking at 4 kilobytes worth of data right now, right? My heap file is always going to come in 4 kilobyte multiples. 4 kilobyte multiples. So if this page were to get filled up, I would expect then you to be able to detect that fact, make a new heap page, and then add another 4 kilobyte chunk onto the end of this file. In fact, that would be a great test. It would be a fantastic test. Keep adding tuples to this file until you know that the first page is full, then add one more and see if it created a new page and properly added it onto the file. That would be a wonderful test. If you guys don't write that test, I will. That is a very important test to do. Okay. Let's see. I want to make sure I checked off everything on my to-do list to chat with you guys about. Did the overview, talked about the data files, talked about unit testing, working the repo. That's all good. One final logistical thing. A lot of you already signed and filled out the Academic Integrity Pledge last time. There were several of you who did not. Just as a reminder, I'm not grading any of your stuff until I have a signed pledge in my hands. So if you weren't here last week for whatever reason, you weren't able to get that signed, make sure to come pick up one of these before class is over today. If there aren't any questions right now, what I'd like to spend the last 20 or so minutes doing is maybe writing a couple unit tests for you guys, just to get some practice doing it, just to talk about it. We could even write that one I was just talking about with the heap pages. Right? We could write that one. Any questions before I switch gears and do that? Any questions? Yes?
I'm just wondering, in the hex file, the header was middle endian?
I believe so.
And the
Yes.
int that spelled out 530 was big endian, right? So we're not using it.
So these are the most significant bits here. Yeah. These are the most significant bits here. But actually, so part of this is set up for you. If you use the infield class that I provided to you, it will properly read in these bytes and parse them for you. You don't have to do that part. That's part of the reason why it's set up this way. Yeah. But the header does need to be treated accordingly. There's really no way around that. The instructions go into a little bit more detail on both things. Great question. Any other questions? Yeah. Yeah.
Can you still elaborate on the structure of what this page exactly is? I'm not, like, I know what hex is, but like, where's the header after?
Yeah, so every heap page is going to start with a header. In this case, we know, I gave you the information that there should be 30 slots in here, and we kind of reverse engineered from that the header should be 4 bytes, because 4 bytes is how much we need to store 30 bits, 1 bit per slot. I could actually get away with 32 slots, but you know, I'm going to run out of space in my page, so I only really have 30 slots. I know there's 4 bytes, so the first 4 bytes here that I have highlighted, that's my header. There's nothing in here that says that's my header. I just know, based on my knowledge of the format of this file, that those 4 bytes are the header for this particular page.
And then after the header's over, after those 4 bytes of the header, it's immediately going to start the data, the slots. So slot 0 starts right here and takes up a big chunk of space. I'm not sure. I'm not going to count out 133 bytes, although it might tell me. Actually, it will. In hex. Oh, great. That's too much math for me to do right now. You know, the next 133 bytes is slot 1, and then the 133 bytes after, or I'm sorry, slot 0, and then the 133 bytes after that is slot 1. But again, there's nothing in here that says here's where it starts and here's where it ends. I just have to know that based on the metadata that I've been given, that there's an int followed by a string. Did that answer your question? Yeah, so it's really comes down to just knowing the format really well. And then once this page is over, let's say I fill this page up and I add another page. It's going to follow the same thing. The first 4 bytes of the next page are also the header for that page, followed by slot 0, slot 1, slot 2, slot 3, slot 4, slot 5. So if I want to get the address of a single tuple, what do I need? I need to know what file it's in. That's actually based on the table, since there's 1 heap file per table. So I need to know what file it's in. I need to know what page it's on. And then I need to know what slot within that page it's on. Those are the quote-unquote coordinates of a tuple. And the tuple itself has some getters and setters set up to help you track this information. So if I look at the tuple class, you can see I've got a page ID getter and setter, and I've also got, I just call it the ID, it's the slot ID getter and setter. I may not know what those values are, right? I may not know what those values are, but sometimes I might. If I just read a tuple out of the file, I can tell it, oh, hey, I found you at this page in this slot, so that then if I want to put that tuple back in, I know exactly where to go. If I'm like making some changes to it and then putting it back, I don't have to scan through the whole thing over again. I can just say, all right, this is where you were, boom. That's where you're gonna go. Great questions. Any other questions? Any other questions? So we've got just enough time left, I think, to write a unit test, just to give you a little taste of what it's like to write a unit test. We've got about 15 minutes left. That's the perfect amount of time. So I want to write that unit test I was talking about, right? I want to write a unit test that tests the case where I need to add a new page to my heap file. I have to add a new page to my heap file. So right now I've got a heap file that's got 1 tuple in it, and if we just think through this, you know, in English first, and then we can turn it into code, I want to fill up that page. I know how many slots it's supposed to have, right? I want to fill up that page, and then I want to add 1 more tuple. That should force it to create a new page, and then I can just say, how many pages do you have? And hopefully it will give me the correct answer. Right? So which part of this program is responsible for managing pages? What's the hierarchy like? Remember, there's a hierarchy here, right? The heap file is responsible for managing pages. Maybe that'd be a good thing to get down in writing for the sake of the video and your notes, right? At the very bottom, the lowest level of data that I'm managing is what? The records, which in our case are tuples, yeah. All right? And then what manages the tuples? If I want to insert a tuple, where's it actually going? It's going into a heap page, right? Oh man, my writing is worse than normal. Sorry. All right, and then I just asked you what manages the heap pages, right? That's the heap files. And there's actually one more level of the hierarchy above that. There's something that's managing the heap files, or actually the tables, which is the catalog or the database. I would kind of accept either one. DB, oh, that's not a D. DB/catalog. So here's kind of the hierarchy of this assignment, right? And of our database implementation. This is important for you to know. This is important for you to be aware of as you're working on this assignment, because if you get stuck somewhere, if you figure out where a problem is, you need to know who's responsible for that piece so that you can go fix it. In our case, we're talking about what happens when I need to add a new page. Who's responsible for managing pages? Heap file. So this test that I'm about to write should be testing the heap file behavior, since heap files are responsible for managing pages. Does that make sense? Does that make sense? All right, cool. So let's try to write a quick test. I want to write a test based on the heap file. So I'm going to open the heap file test. I know I didn't look at these tests yet, but because we're running a little short on time, I'm just going to kind of speed things up a little bit. You're of course, more than welcome to take a look at these tests and ask any questions that you have about them. I'm just going to make a test called test new page. Okay? 3 steps. First thing I need to do is set up the testing conditions. Set up the testing conditions, which in this case I think might actually be well, what do you think the testing conditions are? What do I need to do to get this ready to test what I'm trying to do here? I want to add a new page. So what has to be true? My current page has to be full, right? So I need to write code that's going to fill up the current page. Right now, I know that this test file has 1 tuple in it, and a page can hold 30 tuples total. So if I add 29 more tuples to that, it should fill up that page. Does that make sense to everybody? I started with 1 that's already in the file. If I add 29 more to it, it should give me to 30 tuples, which should fill the page to capacity. So it doesn't matter what content is in the tuple at all. That's irrelevant to the test. So I'm just going to steal this code that I've got from a different test to create a tuple for the sake of time. Let me put some comments in here so that we understand, right? Make a tuple to be inserted. All right, there's my tuple. Now I'm going to insert this tuple 29 times. Insert tuple to fill page. And I can just write a loop to do this. Remember, at the top of the file and in the setup function, I've got some instance variables available to me. So here's heap file. How do I put a new tuple in here, right? Well, there's certainly a method to do that. I don't necessarily remember what it's called, but Eclipse can maybe help us out here. Or freeze. Come on. It's trying, you guys. It's trying. All right. Oh no. Don't do that to me. It actually showed it on the screen. There it is. Okay. And it's right up at the top. Add tuple. That's what I want. Add tuple. That sounds like the way to go. So I'm going to add this tuple called T. I'm going to do it 29 times, right? Insert the tuple to fill the page. Everything we've done so far, that's setup. Everything I've done so far is just setting up. Yes, question.
Why exactly are we inserting 29 times?
Because I want to fill the page. I'm testing the case where a new page needs to be added, and that's only going to happen if all of the other current pages are full. So I'm trying to fill the page, and then I'm going to add 1 more tuple, which should trigger it to make a new page. Does that make sense? Yeah. So this is all set up. Everything that we've written so far is just setting up the testing conditions. The next thing to do is to run the test itself. And I think it's important to keep this separate, right? I'm going to add the tuple 1 more time, and you might say, well, why not just make the loop run 30 times instead of 29? And you're not wrong, but I actually like to keep this separate because this is the part where I think that things might go wrong, right? Things might break here. So I think it's actually valuable to keep this portion separate. So I'm just going to call it 1 more time, hf.add tuple t. And I'll put a little comment here, right? Page 0 should be full. Adding 1 more tuple should cause it to make a new page.
That's what I'm expecting to happen. Will that actually happen? I don't know. I hope so. I hope you guys figure out how to do that, right? But this is what I am expecting to happen. So we've done step 1, that's setting up. Step 2 is running the actual test, which is just one line of code. Actually, step 2 is almost always going to be one line of code. Call a method, right? One line of code. Step 3 then is to verify that the results are what I expect them to be. So somewhere we need to have some way of figuring out how many pages are in this heap file. So we could see if there's an existing method for that. In fact, there is get num pages, right? And after this, I expect there to be 2 pages, right? The one that was in there plus the one that should have gotten added. I expect for there to be 2. But for a unit test, the way that we actually do this is we write what's called an assertion. I'm going to tell you that this is what I expect to happen. And so the way we do that is we say assert true. That's one way of doing it. There's probably a bunch of different ways I could actually do it. Verify results. And there we go. We've done it. We've written a test for adding a new heap page to a heap file. I got to tell you guys that this is actually probably one of the more complicated things, one of the more complicated parts of the lab. If you get this test to pass, you're in really good shape. You're in really, really good shape. There might be other things wrong with your code, but this is a tricky part of the assignment to get. So if you can get this right, that means you're going down the right path. And so as far as other unit tests go, if you're thinking about tackling the unit tests, thinking about writing some unit tests, they're not going to be, in general, any more complicated than this. I would not expect them to be. And if they are, you should maybe stop and think to yourself like, maybe I'm trying to do too much here. Maybe I should split this up into multiple tests, perhaps. What questions do you have for me? So this test is already coming back to you. You can't give me this test as part of the extra credit anymore. I took it. It's no longer yours to have. But there's plenty of other opportunities. Trust me, there are lots of possible things that could be tested. If you have any questions about it, I'd be happy to chat with you about this during office hours or online on Piazza. Whatever way you have to get a hold of me after class. I'd be happy to chat with you about this. If you can't tell, right, this is something that's important to me. This is a skill that I feel like you guys should have when you leave here, and I'm trying to make that a big component of this class. So please consider doing this for the 5 bonus points, if nothing else. Get those submitted to me by noon on Friday. And keep in mind that I'm going to keep asking you to do this. We're going to keep having more conversations about testing as the semester goes on. Anything else right now? Anything at all? Again, reminder, I need to have one of these signed by you and given back to me before I grade your stuff. So if you haven't done that, if you didn't do this last week, come up, grab one of these, do it now. Otherwise, that's all I got for you guys for today. Good luck on the homework assignments. Have a fantastic weekend, and I'll see you back here on Monday.